soon after the first mission to a near-Earth asteroid. Now, it turns out that both the Mars flyby mission and the mission to near-Earth asteroids require less delta V than a mission to land on and return from the moon. So there's less propellant required. You can get bigger payload. Next mission, Obama said that he has a goal of mission to orbit Mars in the mid-2030s. Now, the problem with this plan is that it's not nearly as aggressive as it could be if more funding were available. Now, our understanding of asteroids has changed greatly, especially since the time I went to school. It was once thought that nearly all asteroids resided in the main asteroid belt between Mars and Jupiter. Well, we now know that there are a significant number of these asteroids in the inner solar system. Those whose orbits bring them close to the Earth are called the near-Earth asteroids. Now, it was once thought that these asteroids and comets, for that matter, were no threat to the Earth. Now, this changed with a theory which was first proposed by Walter and Luis Alvarez in 1980, that the dinosaurs became extinct due to an asteroid impact 65 million years ago. Now, this theory is now widely accepted, and other mass extinctions has also been linked to asteroid or comet impacts. The number of known asteroids is increasing at an accelerating rate due to new space telescopes and also land-based telescopes. And two examples would be the WISE space telescope, that's a Wide Field Infrared Survey Explorer, and the Pan-STARRS is a land-based telescope based in Hawaii. Since 1990, we have discovered dozens of small asteroids with orbits that are very similar to that of the Earth's orbit. Now, these asteroids provide an opportunity for a human mission to Mars in only about 6 months' time, and that's compared to 2.5 years for a human mission to Mars. As of May 2010, over 7,000 near-Earth objects have been discovered. Almost 7,000 are near-Earth asteroids, but also 84 near-Earth comets have been discovered. 1,125 of these are classified as potentially hazardous objects, that there's a threat that they could they have orbits that eventually, over a long period of time, might have a collision with the Earth. Now, this picture shows the orbits of all near-Earth asteroids that were known as of the beginning of the year 2000. And at that time, we only knew of 800 near-Earth asteroids. The current count is over 7,000. So it would be much more garbled than even that picture now. Near-Earth asteroids are very easy to reach. They require a much smaller delta V, change in velocity, and therefore less fuel than a mission to land on and return from the moon or from Mars. They can be accomplished with a single launch of an Ares 5 class heavy lift booster, and a mission to one of the smaller ones with an orbit nearer the Earth is only 6 months, or less even. And since it's only 6 months, you don't really need artificial gravity that the astronauts routinely take missions to the International Space Stations of 6 months duration. And there will be much less radiation exposure than a mission to the moon because of less time exposed to interplanetary space. Now, later near-Earth missions, you'd want to expand. The second mission might take a year, a third mission, a year and a half. So for the later missions, you would want artificial gravity. Lockheed Martin proposed an interesting concept. They looked at whether you could do a near-Earth asteroid mission just using the hardware that was available to the Constellation program. Lockheed Martin was the contractor for the Orion spacecraft. So they proposed using 2 Orion spacecraft that are docked nose to nose. And you can see an asteroid in the background, and if you look very carefully, you can see a human figure standing on that asteroid. Now, they studied this in 2007, and they were going to use the one launch of the Ares 5 heavy lift vehicle. That rocket is not human rated, so they would take the humans to space with the Ares 1, and 2 Orion spacecraft, and a crew of only 2 people, because that's all they could essentially fit with all the supplies that they needed to take on the mission. And they concluded that this was feasible, provided that you restrict the missions to not much more than 6 months. Now, this really isn't the best way to do it. For human missions, you'd want a habitation module because you need greater volume. You need enough volume for a storm shelter, from solar flares, for a kitchen. You'd like private sleeping quarters for the astronauts, etc. Now, once you have this habitation module, it can then be used for a Mars mission. The only addition that you'd have to do is add a descent system to land the habitation module on Mars. So here's an example mission that they looked at. There's an opportunity to launch to asteroid 2008 EA9 in the year 2019. And it's a mission that would take about 205 days. That's a little less than 7 months. You'd take off, you'd launch November 15th of 2019. The outboard trip would be 94 days. You'd arrive at the asteroid and spend 5 days exploring the asteroid and retrieving samples. Then after 5 days at the asteroid, you depart, and it would be a 106-day return trip, and you'd land 205 days after the mission was initiated. Now, asteroid EA9 is a very small asteroid. In fact, it's only about 10 meters in size. Most of the asteroids that are really close to Earth and accessible are very small. So how would you collect samples from this asteroid? Well, you'd first rendezvous with the asteroid and observe it from a distance of maybe several kilometers away to do some general mapping of the surface and also to make sure that there's no co-orbiting debris. Then you'd station keep maybe 100 meters or so from the asteroid. Now, you can't land on this asteroid because it's too small. And you can't walk on the asteroid because there's no gravity, so you can't do something like a moonwalk. So you have to do a spacewalk. So you'd use something like MMU, that's a manned maneuvering unit. Those are used like by the space shuttle astronauts. They've got little pack on the back, which has rocket thrusters that can maneuver them around, and they'll approach the asteroid and collect samples. Now, it could be that the asteroid is rotating, which provides a slight complication. In fact, we've observed that many of these near-Earth asteroids that are that small have rotations that are as fast as a few minutes per revolution. So it's still a manageable rotation to collect samples, but it does complicate matters. There are actually many questions still to be resolved about how best to do EVAs with very small asteroids. Now, as far as safety considerations, the Augustine Committee looked into that, and they concluded that this flexible path strategy and the Moon First strategy are equivalent as far as safety is concerned, because you have a trade-off. With near-Earth asteroid missions, you're further away from Earth if something goes wrong, but on the other hand, you avoid the very risky ascent and descent from the Moon. A mission to Mars, of course, with landing on Mars would be more risky, much more risky, but that's precisely why you need a program like the flexible path to alleviate the risk and to test out all the equipment carefully before you actually do a landing on Mars. Now, as far as the science considerations are concerned, the Augustine Committee also looked into that, and they concluded that the flexible path strategy has a higher science return than return to the Moon does. From the Apollo missions, we've already collected more than 800 pounds, 842 pounds precisely, of lunar rocks from 6 different locations on the Moon. In addition to that, 3 Russian sample return missions collected samples from 3 other locations. So we already have samples from 9 different locations on the Moon. Near-Earth asteroids contain material that dates back to the very beginning of the solar system. So scientists are very interested in that. It will help them determine how the solar system was formed. In April of this year, 2 teams of researchers working independently announced the discovery of both water in the form of frost and organic molecules on the surface of asteroid 24 Themis, which was covering most of the surface of this asteroid. Now, this was a very surprising scientific discovery because it was unexpected. It's the first time that we've detected water actually on the surface of an asteroid. And theoretically, they couldn't figure out why it was there. It should sublimate away over a few years. But apparently, water in the form of frost did cover most of the surface. And it was verified by 2 teams independently making observations. So it's probably correct. So whether this water comes from an internal source on the asteroid or just how it is formed, we don't really understand yet. But why is the fact that some asteroids contain water and organic material important? Well, one reason is that there's a great mystery about where the Earth got all the water from that fills its oceans. Now, scientists know that very early in Earth's history there was a collision with a Mars-sized body that actually formed the Moon. And when that collision happened, the Earth should have been stripped from all its water because of the heat and intensity of that collision. But yet we have a lot of water in the oceans. And we also know that this water almost certainly doesn't come from the comets, because the comets, the water that we've detected in the comets have a different isotope ratio than the water in Earth's oceans. So where does this water come from? One theory is that it may come from the asteroids. And we don't really know how much water the asteroids contain. So this is of great interest to scientists to find that water, find out what isotope ratio it is. Also, by studying the various kinds of organic materials present and their relative abundance, we can gain insight to how life may have formed. So the flexible path strategy also enables human missions to serve as space telescopes, which is another plus for science, at servicing these space telescopes at the Lagrange points. Also, on the Mars flyby mission or Mars orbital missions, it enables the astronauts to operate rovers on Mars via telerobotics.